This video shows how to solve a series parallel circuit. So here we have a circuit with 8 resistors, R1, R2, R3, R4, R5, R6, R7, and R8. So I have 8 resistors of various values. And so I have several nodes here that I've already color coded and labeled. So I have node A, node B, which is all of this up here, node C, which is connecting these 3 points down here, node D, which is my ground node, and also node E, which is connecting these 5 resistors. So I've color coded these and labeled these. Now we would need to go through and just try to start identifying resistors. So our source is here at the left. We have 100 volts, and so in general we want to try to start from the right and work our way back to simplify this. So if we look here, we have B and E. So these 2 resistors, R3 and R4, are sharing the same nodes, and so these 2 resistors are in parallel. So I'm going to take these 2 resistors and replace them with a single resistor using the parallel equation. So I'm going to have R3 in parallel with R4 is 1 over 3K plus 1 over 6K. So if we calculate that, so we'll get R34 is equal to 1 over 3K plus a 1 over 6K, and that gives us a 2K. Now notice in this case, since all the resistors have the K for kilo ohms in them, that I just kind of left that out in my calculations. So as long as you're consistent and you know each one of these has a kilo prefix along with them, then when you get your solution, remember that it also has a kilo. So R3 in parallel with R4 gives me a 2K ohm resistor. Also down here between E and C we have R6 and R7. Now notice that these also have a 6K and a 3K. And so I'm just going to clean this up a little bit here, but so we know that this is a 2 kilo ohm resistor, and so R6 down here also is a 6 kilo ohm resistor. Or excuse me, R6 was a 6 kilo ohm resistor, R7 was a 3 kilo ohm, and so this also gives me a 2 kilo ohm resistor. Alright, so but I do want to point out here that that this resistor here is not in series or in parallel with this combination, right? Because right here at point E we have current can come down this way, but it can split and go off in either direction. Okay, and they're not in parallel either, because this is node E, this is node C, and then this is node D. So we need to kind of look for something else there. So if we look, we can see that, hey, wait a minute. If I have current flowing down through this parallel combination of a R6 and R7 into C, all of that current must also run through R5. So R5 is in series with the parallel combination here of R6 and R7. So this gives me this parallel combination, or this series combination of R5 plus the parallel combination of R6 in parallel with R7. And so that's a 2K plus an 8K makes this a 10K, 10 kilo ohm resistance. Okay. Now I've redrawn this so that we can see that R8 is in parallel with this combination resistance here. So the R6 in parallel with R7 plus R5 in series is in parallel with R8. So I can now take these two, find an equivalent resistance between those. And so that would be R8 in parallel with this combination, which I'm just going to call R5, 6, 7. So that's the combination of 5, 6, and 7. All right. And so that gives me a 1 over 2K plus a 1 over 10K. So I'll flip back to the calculator here and try to calculate that. So we have, so then this resistor, then we're just end up calling this R8, 5, 6, 7. Alright, so this is R8, 5, 6, 7, which is equal to 1 over 2K plus a 1 over a 10K. And we get that to be a 1.6667. Alright, so if we were going to put that into Blackboard, so the value of this again is 1.6667 kilo ohms. So if I was going to put it into Blackboard, I would put in 1.67 kilo ohms. But when you're doing in intermediate calculations, remember to always keep it out to at least 5 digits. Okay, I didn't have to really worry about that with the 10K or the 2K up above because those were nice even numbers, and so they're actually exact, so I didn't have to record them out to that value. But if I was going to put it like this 10K resistance in Blackboard, I would have to write it as 10.0 kilo ohms to get my 3 significant digits. Alright, so now that we look at this, we see these two are in parallel. Alright, we've already calculated these two are in parallel with this equivalent resistance of 1.67 kilo ohms to 3 digits. And so now this resistance of this parallel is going to come through here and it's going to go through this resistance. That is a series connection. Alright, so we can combine that. So this resistor here is all of that combined. So that is resistor R3, which is in parallel with R4. And then we have our 5, 6, 7. And I'll just round that one up to 8. So this is equal to now the R3, 4 parallel combination plus the R8, 5, 6, 7 combination, which are in series. So this one is shown right here, 1.6, and I'm going to go ahead and write it out to my 5 digits, so when I do any calculations I have it to that accuracy. And then R3, R4 parallel combination was 2K. So 2 point, and that, that was just an even value there. We can write it out to 5 digits too if you prefer. That gives me a 3.6667 kilo ohms for this combination. Okay. Now looking at that combination, we can see that R2 is in parallel with that combination. So we can then take these two parallels and replace them with a new resistor, which is these two in parallel. So it's the 2K in parallel with the 3.6667K. And so we'll call that one R2, 3, 4, 5, 6, 7, 8, which is this parallel combination. So that's a 1 over 1 over 2K plus a 3.6667K. And so that there, we'll flip that over to the calculator here. We'll calculate that. So we've got R2, 3, 4, 5, 6, 7, 8, which is 1 divided by a 1 over 2K plus 1 over 3.6667, okay, which gives us a 1.2941K. Alright, so that gives us a 1.2941K. So now this resistor here now is in series with R1. So we get R total. So we get the R total is R1 in series with this. So it's R1 in series, so it's just added with this 2, 3, 4, 5, 6, 7, 8 combination. So that is simply 8K plus 1.294 1K, and so that's going to be 9.2941 kilo ohms. And so to put that in blackboard, the total resistance would be 9.29 kilo ohms. We could therefore calculate our total current. All right, so the total current through node A into this equivalent resistance. Now this resistor doesn't actually exist, but this is the equivalent resistance that the original circuit shows to the 100 volt power source. And so we can calculate this current here at I total, which is also equal to I1, the current through the resistor R1. And so we can calculate that current as being 100 volts divided by the total resistance, and we'll use the 5-digit one just for accuracy, so 9.2941. So we're going to have our I1 current is going to be the 100 volts divided by our total, which is going to be 10.759 10.759 amperes. So we can also, now we know that is the current coming out of the battery into resistor R1. So we can actually now start working our way back up through these other circuits, and we can find the voltage drop V1, which is the voltage drop across R1. Using Ohm's law, we know that the V1 is equal to I1 times R1. So we take this current, multiply it times the 8 kiloohms. So we get that V1 is equal to I1 times 8, which gives us 86.076 volts. We can also determine then the voltage drop across R2, because Kirchhoff's voltage law tells us as we go around the loop, we end up with 0. So we take this 100 volts, take the 100 volts and subtract this 86.06. .076 volts, and so so V2 is equal to the 100 volts minus V1, which is 13.924. So we can come over here and say that this voltage here is 13.924 volts. Okay. So now we can actually go up to this circuit and we can specify these voltages. So we know that this was 86.076 volts, and then voltage V2 was 13.924 volts. Okay. And we can calculate how much current is going to be flowing through R2, because we know that it's 2 kiloohms, so we can find the current. So we take V2 divided by 2 gives us 6.962. So this current is 6.962 milliamperes. Okay, remember we've got K's on our resistors, so our current's in milliamperes. All right, and so we can determine how much current is flowing through into this load, because we know that our total current down below here, we had the total current was 10.759. So we have that I1 was 10.759 amperes, and we're losing 6.962 coming down through R2, so whatever is left must be going on over to the right. So we take this calculation here was actually I2, the current I2. So we could calculate the current over to the right is I1 minus I2. That's Kirchhoff's current law. And so that gives us 3.7974 amperes. So we can say that's 3.7974 amperes. All right. And so we can then find the voltage between point B and point E, because we know this resistance, R4, R4 in parallel with R3, I think that was 2K. Yes, that was 2K. So that was equal to 2 kilo ohms. And we know the current, so we can find the voltage drop. So we can find the voltage drop across this resistance. Okay, and so using Ohm's law, we can take and find that the voltage 3,4, so the voltage 3,4 is the current 3,4 times the resistance of 3,4, right? And get that voltage drop, which is 2 times 3.794, which is 2 times I right, 7.5949. Okay, so that gives us the voltage drop. So we can come up here, and that's the voltage drop between B and E. So even we can come back up here to our original circuit and say that the voltage drop right here is this 7.5949 volts. We can say that the current 3.794, all these values apply up here anywhere those nodes apply. Okay, so we can calculate that. So we know that if we go around this loop here, let's look at 'kay. Let's see, so we take this voltage here, which is the voltage across R2, okay, and so that's this voltage right here. And so we know that is, if we start at point D right here, go up through R2, down through R4, and through R8, right, that's a loop. And Kirchhoff's voltage law tells me that if I go through a loop, I should get back to zero. So as I go up, I will go up 13.9 volts. And then I come over here, I go down 7.59 volts. So I can find the voltage, using Kirchhoff's voltage law, I can find the voltage across R8. So that is the voltage V2 minus the voltage V34. So the voltage across the resistor 8 is 6.3292. 6.3292 volts. And the polarity of that, the current is going to be flowing, the voltage is flowing up through this, so it's going to be coming down and then back from right to left through R8. And so we can go through there, and we can just take this current, or this voltage I mean, and just right there is the voltage. Probably should have been pasting them in here like this before, but the So that is 6.3292 volts. And so then we now can use Ohm's law. We can find the current through R8. We can apply Kirchhoff's current law and find out how much current's flowing through here. We know this voltage, so we know what the current is through there. We know what the current is through here. So applying these laws, we can just go through and we can determine everything we need to know about all the currents and all the voltages in this circuit. Okay. So again, I'm not going to go do the rest of those here. I'll just leave that for you to finish. But if you just remember that you want to start by simplifying the resistors, identify any resistors that are in parallel, or identify resistors that are in series, and simplify and then redraw. And then identify some more things in series, simplify, and then redraw. Okay, so identify if it's in series or parallel, anything that you can combine them, redraw the circuit, record all these values, and then anytime there's any nodes, so like you see here, right, we had basically 5 nodes, A, B, C, D, and E. But when we get to this point, we lost node C. Node C is buried over in here, so we don't really have access to it in this drawing. But the other nodes we do. So once we find the voltage between B and D, that voltage between B and D in any one of these versions of the circuit. So remember, this was the true circuit. And the rest of these are just simplified based on the way what the voltage source is seen. Alright, so as far as the voltage source it can tell, every one of these circuits are exactly the same because they're all drawing the same amount of total current. And so the voltage source can't really see into this circuit and see that there's 8 resistors. All it knows is that there's an overall combined resistance, which for this example turned out to be 9.29 kilo ohms.